Let's begin. Today's September 24th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 15, 18, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card B will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card C again looks at our 3 digits, triangle, square, and circle, but this time it'll add them up together, and the Turing machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D looks at the first 2 digits, triangle and square, adds them up, and compares the sum to the number 6. So should the sum of the first 2 digits be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E looks at our 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there's a pair in the 3-digit code, as in the example 131, or alternatively, there are no pairs. But there are 2 scenarios, one where all the digits are different, as in the example 134, or the other case is where there's a single digit repeated 3 times, as in the example 222. Remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is a little bit more about that first digit. So let's go ahead and test criteria card A. Okay, so the Turing machine approves of my choice for triangle. I did choose an odd 3, so the Turing machine agrees that triangle should be an odd digit. So let's go ahead and type that up in our notes in section A. And that again is that triangle is odd digit. And of course, since it is odd, we can cross out all of the evens. So it can't be a 2 or 4. Okay, next thing I'd like to test is criteria card. Let's go ahead and test criteria card C. Okay, so in this case, the Turing machine does not approve of my proposal. Remember, again, criteria card C is adding up all the digits. So let's go ahead and do that with my proposal. So 3 plus 1 is 4. 4 plus 4 is 8. I came up with an even quantity, but the Turing machine disagrees with that. So it's letting us know that the sum total of the 3 digits should indeed be odd. So let's go ahead and type that up in our notes for section C. And that again is that triangle plus square plus square plus circle should be odd. And let's see what we can say about what we have so far. So we have established that triangle is already odd, and so that leaves square and circle to be either 2 possibilities. Either they're both even or both odd. Now the reason that works is regardless if they're both even or both odd, whenever you add 2 like types of numbers, either being of course 2 evens or 2 odds, that sum total is even. And if you add an even to an odd, which we know triangle is, that would establish that the overall sum would be odd. So that means that we have 2 possibilities. Again, either square and circle are both even, or both odd. And so let's go ahead and now test criteria card E. Okay, so the Turing machine does not approve of my proposal. In this case, we're looking at either pairs or no pairs. Well, 3, 1, 4 are all different digits, so that falls under the no pairs scenario. However, the Turing machine does not agree with that. So it's actually letting us know that there is a pair of digits. So let's go ahead and type that up in our notes for section E. And that's that the solution has a pair. Okay. Now, of course, we don't know if they are even. Well, then we know that that square and circle are even, or again, they could be odd, or they could be an all odd solution, and maybe triangle's the one that's paired up. We just don't know. Okay, well, we have concluded our round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So we did test criteria card B, which actually is pretty important, because now that we know that we have a pair of digits, we know that whichever digit is not paired up, that has to be the largest, because of course when you have a 3-digit code with 2 numbers that are paired up, well, it's the case that the one that's not paired up is either the largest or the smallest. In this case, criteria card B will let us know that it's the largest. We also did not test criteria card D, the sum of the first 2 digits, and so it really comes down to those 2 cards. How can we somehow use this card to help us out? I guess the sum could be 6 with 1s and 5s, and then circle would be forced to the other digit. I guess it would be the 5 that would be the largest. That would be interesting if the largest were part of either triangle or square. So what would it, well, let's actually do the opposite. What if circle is the largest? So if circle is the largest, then triangle and square would be paired up. And so we'd have a sum that's less than 6, equal to 6. But obviously with a 5, it couldn't be greater than 6. That would be interesting. Let's see, what else can we say about the sum? Well, and if the sum were, if triangle and square were the ones that are paired up, it would be an even quantity, but again, I think that's secondary to the fact that they'd be less than 6, equal to 6, or greater than 6. What if they're not? They can still be all odd. That's still a possibility. Yeah, I don't know if there's anything really here that would establish the 2 paired up numbers as even. So yeah, what if it were, again, 2, 2? How would you how would you establish that fact? I guess you could say, yeah, the sum is less than 6. But it's got to be the largest. So it couldn't be 1, 2, 2. It could be 3, 2, 2. Triangle's the biggest. But I guess the question, why wouldn't 311 work? So 1 can't be the biggest. 3, if 3 were the biggest and the sum is less than 6, well, you'd have 2 possibilities. So I don't think that would work. So yeah, I don't see, let's see, triangle. Okay. What if triangle 5 were the biggest? Then you'd have, you'd have multiple possibilities where, they're greater than 6, 5, 4, 5, 3, 5, 2, but not equal to 6. So that would be 5, 1, 1. So they're equal to 6, 5, 1, 1. And that's the only way, right? Because it couldn't be 1, 5, 5, because again, you need a maximum. So the only value for triangle that would work seems to be 5, 1, 1, if triangle were the largest. And I guess if square were to be the largest, I guess it could be 3, 5, 5. But also 1, 5, 1. Interesting. Square is the largest, and it's 6. Yeah, I think that would be too simplistic if either triangle or square were 5 and the sum were 6. I think it'd be too easy to say, oh yeah, of course, it's 1, 5, 1, or again 5, 1, 1. Maybe. Yeah, I don't know. I'd like to establish or exclude at least one of the digits, but I don't know if I can do that. So again, 1 can't be the largest for any. So I don't think circle could be 2, because then, of course, triangle and square would be 1. But that's if it's a 2. What about 3? Same thing. It would force that to be 1, 1. 4. I guess you could have a 6 where circle's the largest. 3, 3, 4. And then 5. Yeah, I don't know, but let's go with let's go ahead and get a sum of 6 for the first 2 digits. And yeah, it may be a mystery as to which one it is, triangle or square. Let's go ahead and do that. So let's go with 5, 1, 1. Okay, well, the whole premise was to test criteria card D, so let's go ahead and do that. Okay, yeah, so the sum is not 6. Okay, so let's see. How can we type that up? I guess we'll say that triangle plus square is either less than or greater than 6. Less than or greater than 6. Okay, so I don't know if we can cross out anything. So if, let's see, I know it can't be 6, 6. So it can't be 3, 3 as a double, but that doesn't mean that it can be 1, 1 or 5, 5 if they were doubled. Well, let's go ahead and test criteria card B. Okay, it's also not true that triangle is the largest. Yeah, in retrospect, I'm wondering, maybe I should have made circle the largest, and if it failed, I'd know that either triangle or square would be the largest, and that could have maybe helped inform me a little bit more about the sum of the first two. Okay, well, let's go ahead and type that up as either square or circle is the largest. So let's go ahead and type that up. And that was for criteria card B. So it's either square or circle that is the largest. Well, that's interesting. The largest. Okay, so what does that mean? Can I cross out anything? Yeah, I think we can establish that, yeah, triangle can't be a 5, right? Because if triangle were 5 and it's not the largest, what would the largest be? On the other hand, I don't think we can necessarily cross out the 1s for either square or circle. Okay, wow, well, that basically does it for this round, because yeah, A, C, and E are all established. Yeah, this is another case where I feel like I might have hamstrung myself by not maybe testing criteria card D in round 1. So, yeah, because, yeah, there's no purpose in testing A, C, or E in this round. Okay, wow, not good. Okay, so let's see, what else, did we learn anything? If triangle is not the largest, then we know there's got to be a pair of 1s or 3s. Ah, very interesting. Yeah. Okay, so we have a pair of 1s where 1, yeah, so that means, yeah, either a pair of 1s or a pair of 3s. So let's go ahead and do this. Let's actually start typing out all the possible pairings of 1s and 3s. And I guess we'll say, let's start off with triangle and square being the paired up 1s. Okay, so if triangle and square are 1, 1, what could circle be? Well, it does need to be an odd. So it would be 1, 1, 3, 1, 1, 5. But under those two scenarios, I would say those are ambiguous. How would you distinguish 1, 1, 3 and 1, 1, 5? There's nothing in the cards that would pinpoint what circle should be. So yeah, so I don't think it's going to be triangle and square to be the paired up digits with 1. What about now 3, 3, and it can't be 3, 3, 5 either, because we know that the sum of the first two can't be 6. Okay, so we know that square must be the largest, because circle failed when we took triangle and square to be equal. Okay, so we know that it's got to be triangle and circle to be the paired up, and so that would be 1, 2, 1, 1, 3, 1, and it can't be 1, 2, 1. I apologize. Let me do that, because that is not a sum that's odd. So 131 and 151. Okay, so those are, and then it would be 353, and that looks like the only case. Wow, is that really it? Interesting. Okay, and of course we know it can't be 151 because that sum of the first two is 6. So we can cross that out. Oops. What am I trying to do here? Okay, there we go. And so, yeah, it comes down to what is the sum? Is the sum smaller or larger than 6? So I believe those should be the only possibilities. Yeah, sure does look like that way. Okay, well, let's pick 353. And we'll test criteria card D, since that's what seems to be the the quality that differentiates them. So let's go ahead and, oh, I typed it in, but I have to go to the next round. Now I can type it in, 353. Okay, so let's go ahead and test D. Okay, so it is the case that the sum is not greater than 6. And so there's just way too much stuff to cross out. So let me go ahead and just type it up and we'll review quickly. The solution is 131. Okay, so let's review. Is the first digit odd? It is. Now we are deducing at this point that square is the largest. So that may be an open question, but let's go ahead and continue. Yeah, the sum of the 3 digits is odd. We have established here that the sum should be less than 6. Okay. And that's because 6 failed and 8 failed, which are equal and greater than 6. So yes, the sum should be less than 6. There should be a pair, and that's it. So let's see. Well, let's go and confirm. Okay, yeah, that worked out. Fantastic. Well, now, how do we do versus a Turing machine? I'm thinking not well, because we did go to a third round, even though we only did 6 tests. That's often not a good sign. So let's see, what did we do? We did ACE in the first round, and then BD in the second round, and then D again in the third round. And the only thing we got right was A. Okay, so let's see, let's type that up. So ACE. So A was correct, C and E were incorrect. Second round, B and D were incorrect. And then third round, D was incorrect. Yeah, as I suspected, the Turing machine did it in 6 turns. In 6 questions, just like we did, but it took 3 rounds for us to complete it. So yeah, that's why we did not beat the Turing machine this time around. I will say though that at the very end, now notice what we crossed out. That's pretty impressive to still get the correct answer. Obviously, we did in 6 questions. We just weren't as efficient. Again, I blame myself for not choosing criteria card D in the first round, but sometimes it's, at least I don't tend to evaluate too much all the cards. I have a certain pattern and obviously or way of doing it, and it failed on this puzzle. So as far as, beating the Turing machine, obviously we still got the correct answer. So I probably need to do a better job of maybe evaluating the cards maybe before. Not sure what I should do. But I will say that even though criteria card B did not work out, it was, I think, critical to then make the conclusion that, okay, so if triangle isn't the biggest, it's paired up. I know maybe in retrospect, of course, that makes sense. But when you're in the middle of the puzzle, sometimes, these ideas or simplifications just don't pop up. And so I think that was critical in then establishing, especially since now we only had two choices for triangle. It was easy to say, okay, so that means it's got to be 1-1 or 3-3, the paired up, and then trial and error as we listed the possible solutions. So I think, I still think it's a great puzzle, and I'm happy with the results, but there's room for improvement. Well, what do you think? Any additional thoughts or critiques? What did you notice? How did you solve it? Add those ideas in the comment section. If you like the video, give it a thumbs up, and of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.